the Knots guys, they have this idea that we expect Bitcoin to be run by people who will do things that's not in their financial interest for the greater good. That doesn't really sound like the ethos of Bitcoin.
Peter, thank you so much for coming. I'm so excited that you're here in Atlanta. Yet again. And shout out to Tidwell. We're going to give Tidwell a shout out for making this possible. So thank you to Michael Tidwell for bringing us together in this lovely city in the Southeast. How's TabConf going for you?
Same as before.
Did you fly here from the Ukraine? From
Kiev. Yeah.
Oh, you did?
Well, I mean, not from Kiev. The planes are shut down right now. But yeah, I took a train to Poland and then another train in Poland and yet another train in Poland. Then a flight to Istanbul, then a flight to here. By the time I was here, I said, you know what? I'm getting an Uber.
Okay, yeah, then you sprung for the Uber once you were in Turkey.
I'm not taking the train one more time at that. Yeah.
Oh my gosh. Well, yeah, you're an interesting, colorful character, but you...
Well, and tonight, before even tomorrow, I fly out again for yet another conference.
Oh, so, really? Yeah. Yet another conference. Yeah. Where?
Oh, off in Bulgaria.
Oh, in Bulgaria. Yeah. It's just casual. Yeah,
so just casual. Yeah.
You're back to Europe tomorrow. Interesting. Well, yeah, I mean, you have an interesting... We're going to get into sort of your... some of the work you've done with governments in Bitcoin, which I think is something that's sort of unique to you as a character. But I think, most notably, you've just been in Bitcoin seemingly forever.
Yeah.
When did you get it? 2010 or something?
I think I...
Are you Satoshi? No, I'm kidding.
Are you Satoshi? I think I first learned about Bitcoin in late 2009, maybe.
Okay. Right off the bat.
I vaguely remember someone just telling me, "Oh, you should read this white paper."
How? You don't even remember how or how that happened?
Yeah, it was so long ago. But of course, then I go read it. I remember thinking to myself, "Oh, I should have thought of that."
Really?
It just seems so obvious.
So obvious. Yeah. Why didn't I think of that?
I somewhat famously tried to go and invent Bitcoin and was talking to Adam Back and Hal Finney, and we were all trying to invent Bitcoin basically. And as far as I know, we all failed.
Oh, interesting. Yeah, I mean, as far
certainly
as we
failed.
Know. But you don't even remember. I mean, were you in the cypherpunk mailing list? Why?
Oh, earlier on, I was in something called the Blue Sky mailing list.
Okay, which was?
It was sort of an offshoot of a bunch of people from the Freenet project.
Okay.
Which is decentralized data publication.
Okay.
And obviously, if you have decentralized data publication, surely you got to have a way to pay for it.
Okay, so you came into Bitcoin through a political lens. To
a degree. And also more recently, 2014 recent, when I decided to sort of quit the day job and work in Bitcoin full time. One reason I did that was that I realized Bitcoin's inherently political. And I don't just mean externally, I mean internally. And I like politics. It's fun.
It is one of the most interesting governance structures that could possibly, I think, ever exist. That is a core theme of the show, is just breaking down how Bitcoin governance works and maybe also doesn't always work. So maybe that's a theme that we'll touch on.
Or works in a way that people don't want it to work.
Yeah, exactly. Right. It's all about perspective. I mean, speaking of governance, I mean, you've been somewhat involved. I mean, you've made... Also, you're a very prolific contributor for many years.
Well, a lot less than a lot of people. I mean, my main contribution in terms of hours worked has got to be speaking at conferences.
Really?
Yeah.
Okay. Well, I was going to ask you, I actually did poll, speaking of conferences, I polled everyone at TabConf over the past couple of days that I could get my hands on that might have an opinion. I said, what should I talk about with Peter? And actually, the open timestamps was by far and away the number one project.
Yeah, it's a rare example of a project I've actually completed that actually works.
And it's also interesting because so open timestamps, when did that happen? 2014?
So the very first prototype and first git commit was something like 2012.
Oh, wow.
Yeah. It was kind of like my first Bitcoin project. And, when I made that prototype, my thinking was, well, all right, this is pretty simple. I mean, surely someone's going to do this properly and I won't have to.
I mean, I guess so, but then what?
Well, 2016 comes around and I personally need timestamping. Well, to be exact, 2015 came around. Clients were already paying me to do a predecessor to open timestamps.
Oh.
A simpler version.
Who are these clients? Let's just back up. What is open timestamps real quick?
So it proves data existed in the past.
Okay, how?
And, it mathematically shows that if your data changed, a Bitcoin block would have to change.
Okay.
All right, through one-way functions, hash functions mainly.
As a practical matter, what does that mean? That means effectively inscribe it.
As long as the bad guys don't have time machines.
Okay.
You can rule out attacks because the data existed then. it could have been modified after this point in time, but obviously it couldn't have been because it existed prior to that.
Sure. So it's immutable data recording, reporting.
It's a bit more nuanced than that because you could, for example, timestamp multiple different things at once that contradicts each other. But immutable history is a good term for
immutable history.
It's also the name of a YouTube video that we filmed.
Oh my gosh! Immutable. Wait, what was open timestamps?
So that was
immutable history
by Simple Proof, technically.
Okay.
But they, got some filmmaker to go film this thing called Immutable History, which talks about, among other things, how they used timestamping in the Guatemalan election.
The Guatemala. Okay, so we're going to get into this, how this is actually being used. But as a practical matter, just technically speaking, you're effectively like inscribing a hash onto a block or like into a transaction.
But the thing is, all the world's data only needs one 32-byte digest.
Explain that. What do you mean?
Merkle trees. Right? So with a hash function, you can take something big and make it into something small, such that the smaller data depends on the bigger data in such a way that, at least with the reasonable amount of computing power we actually have access to, you're never going to find two messages that have the same digest.
Okay. But this is like a post Taproot version of this situation. You were
no, it's got nothing to do with Taproot.
Oh no, but I thought Merkle trees are not.
Merkle
Taproot.
trees have existed as long as Merkle trees predate Bitcoin.
Oh, okay. Right? I mean that makes sense. Yeah. Okay, but so you're saying this would be like a use case for Merkle trees having nothing to do with Taproot.
Yeah. No, Taproot, like you kind of got it ordered the wrong way. Taproot is yet another example of a Merkle tree being used.
Got it.
Bitcoin itself uses Merkle trees for the transaction tree, and Merkle trees were invented well before Bitcoin. I mean, in fact, one of the first bigger uses for Merkle trees was timestamping, and this was around early 2000s or so.
Okay, so this is basically open timestamps is essentially a way to immutably record data, or historically
to prove data existed in the past.
To prove data existed in the past.
Which makes data more immutable because you can't modify it without having to re-timestamp it.
And you effectively do this through the use of hashes or Merkle trees of that data.
Yeah.
And then the key use case for this is what?
I mean, frankly, any time you're going to store data for the future, you might as well timestamp it.
Okay.
Now, sometimes
just because you might have to prove it exists at some point.
Well, I mean, you might. It's always better to be able to say this archival data that we think has been archived for 10 years actually is the same thing.
But
as
that's
what
expensive.
It was.
Wouldn't that become expensive?
No.
So it's
Merkle
not expensive.
trees mean it's basically free.
Interesting.
Like the actual cost to make a timestamp is really the bandwidth and the tiny bit of CPU power. And we're really talking numbers like, a billionth of a penny. It's absurd how cheap it is to hash something these days on modern computers.
Okay, so who were these clients who were interested in this? And
well, so in 2015, I think it was, I got a client called Verisart that was timestamping data, that wanted to timestamp data about art provenance. And I threw together sort of an early version of open timestamps for them just for that purpose. There were a few others here and there, but like Verisart was one of the better known ones. And then finally in 2016, I had my own reason to go timestamp a bunch of data, and I thought, no one else is doing this. Like, I'm going to have to do it myself. So I sat down for a few weekends and banged out the current iteration of open timestamps.
Oh, wow.
Yeah.
And it's been used in elections, is my understanding.
Yes. So the Guatemala election, it's a paper ballot system, but when they count the ballots, you wind up with a sort of tally sheet of how many votes there were for each candidate in the ballot box, right? Like literally the box, you dump it out on a table, people go count every ballot. Of course, they observe each other counting every ballot and cross-check.
Right.
And finally, they all agree on a sum that they go put on a sheet of paper.
Okay.
They go sign their names. That sheet of paper then gets scanned.
Interesting.
And that gets uploaded to a computer database. And that was the thing we timestamped.
This happened somewhat recently, right? I mean, this was like in the last few years.
Yeah.
I remember when this happened because I know it was, I forget which company, if it was
Simple Proof is the one who did it.
Okay. That makes sense.
Yeah. And that was interesting because, of course, open timestamps is an open standard. It's a
protocol.
Yeah, it's a protocol. There's some centralized public infrastructure that everyone's free to use. But Simple Proof, they kind of contacted me, I think, about maybe a month or two prior to the election actually happening, saying, yeah, we've done all this. Could you please answer a few little technical questions we have? And, we'd love to have you on site just in case anything goes wrong.
That's how it should work, right?
Yeah.
I mean, that's how it should work with open source development.
Yeah,
companies should just use it.
And to their credit, they got essentially everything correct. Like the little questions they had were really minor things. And all I really did for them was I just babysat it to make sure everything was fine and nothing went wrong.
I think the founders were previously at IBEX maybe, or like they were in the Bitcoin protocol world. They weren't new. I know one of the founders, I think, was like IBEX, either IBEX or Osmo, one of the Latin American Lightning payments infrastructure companies.
I'm not sure, to be honest.
They weren't newbies.
They're certainly technically inclined, but...
Right.
And I don't want to be mean to them, but, they're not like the Concordex.
Sure.
Right? Like, they don't fully understand all the crypto backwards and forwards like other people would.
Sure.
But, that's the beauty of open timestamps. You don't need to understand that much to understand how it works.
Yeah.
It's a very simple protocol.
Interesting.
If anything, it's a protocol that's so simple that it took someone like me to actually do it properly, because anyone competent who isn't really that interested in it, like, you need someone who, is competent enough to do it, and then finally has a reason to do it. Because it's a boring thing to do. It's just not that interesting. Like, it's so simple.
I mean, it's interesting. I feel like the Guatemala election made it interesting, right? I mean, this is now all
not
of a sudden...
technically.
Well, right.
The technical aspect of this is still dead simple.
The most technically simple things, though, are often the most usable and most often. I mean, ordinals is very simple. Inscription is very simple, very widely used, very whatever. Not that it's super important, but widely used.
I'd say that's a different case of technology, because those things, the way the technology works is kind of clunky and weird, and almost, it seems, designed to go piss off Luke.
Yeah, which is one of your favorite things to do. We'll get into that.
Yeah.
But you would say this makes like something. I mean, people.
No one criticizes open timestamps for having a bad protocol. It's like, if you're competent, that's what you're going to wind up designing. There's little decisions you can make one way or the other, but it's kind of a design that's sort of just obvious to people who understand this stuff well.
Notably, though, it is a use of Bitcoin being used for something other than money. I mean,
which some people just have, stick in the mud. They just say that's unacceptable.
You basically were, for lack of a better word, inscribing arbitrary data before it was cool. I mean, is that fair?
Well, timestamping was cool for a long time. I mean, Steven Satoshi mentioned it, so.
but effectively,
I did
right?
It efficiently.
I mean, people, I think, have this idea that using Bitcoin as a data storage mechanism is like a new idea, but that is not true.
Oh, no. Yeah, no. If I was to go and look up the earliest mention of this, I would not be surprised if it was like 2010 or even 2009.
That people were thinking like, you could use Bitcoin.
Keep in mind, like Namecoin as an example. Satoshi probably in 2010 mentioned the idea of it. And I'm not going to say Namecoin's a good idea, but the mention came very early.
You'd probably be the right person to like share the history of arbitrary data on Bitcoin. And
not really, because I wouldn't necessarily remember it exactly.
Yeah.
Like,
fair enough.
I personally don't really care about so many of these use cases. Namecoin is an example. I think Namecoin is not actually a good idea. And not because the tech is bad, but rather the
use case.
Well, yeah, like the user interface it results in is bad. Ordinals and inscriptions, I mean, you're trading tokens for no particular reason.
Yeah,
like,
sure.
It's an art project.
Right, yeah, 100%.
Yeah,
But it's interesting. There's clearly been this history of arbitrary data, and open stamps would probably be would be in that category.
Open timestamps technically is in that category, but because it's just timestamping, it doesn't necessarily need.
It's not data intensive.
Well, there are ways to implement it where it doesn't actually put any additional data in the chain. Just uses someone else's transaction and just modifies some of the numbers to act as a mathematical commitment. So technically, it doesn't need to be data publishing, but the easy way to do it is to put 32 bytes of data in a transaction. So
how much data do you need, and where is this?
Well, per redundant calendar, the thing that puts the final timestamp in a transaction, 32 bytes plus whatever overhead you need for the transaction.
Okay, so 32 bytes.
It really is trivial.
Are open timestamps in the arbitrary?
The way it's implemented right now, yes, but the protocol doesn't require that.
Okay.
So the math proof you get when you make an open timestamps proof is just a series of instructions saying hash this, concatenate this, prepend this, whatever, right? And what ends up at the end is ultimately a block header. What happens in between, the math proof doesn't really know about.
Interesting.
So any way of getting 32 bytes into a Bitcoin block is enough.
Is fine.
Yeah.
But so when you say as of right now,
the actual implementation happens to use op return, but it's not necessary.
Okay.
And so one of the reasons why I did it that way was, well, let's suppose miners for some reason decide they don't like open timestamps. Well, I wanted to have flexibility. So there's other ways to get that data in.
Meaning, so like you're saying, you could just move around.
Let's suppose Luke wins this battle.
Okay.
Ocean has 100% hash power. Every transaction containing op return is just immediately banned.
Like just, is that what he's trying to do? He wants to just...
Well, let's just use that as hypothetical.
Okay, fine.
In that hypothetical example, which I don't think is going to happen, but hypothetically,
okay,
I would just switch to embedding that 32 bytes in a different mechanism, like putting it in, say, a Taproot leaf.
Sure.
So,
but so 32 bytes, the op return data limit right now is 80 bytes, right?
Well, as of V30, there's no limit.
Well, right, but pre this V30, it was 80. Am I right about that?
Yes, in Bitcoin knots, it has it as 40.
Oh,
yeah.
So you could put open timestamps even in knots.
Well, by the default, but there are people in the knots community who want to see op return removed entirely.
My understanding is that you and Luke actually got into it. History doesn't, repeat, but it does rhyme in
2014
about op return, and that the resolution of some war that you had with Luke back then was an 80 byte op return limit. Is that accurate? Tell me this history.
Remember, so the op return mechanism, or I should say the idea of that, had been proposed a few times. But as far as I can tell, I'm the one who actually kind of got over the finish line.
Okay.
Right.
And so was this open timestamps related?
No,
was this because this had nothing to do with it?
Yeah, well, so open timestamps in 2012 used a different mechanism for...
Not op return.
Yeah, not op return. For a while it was using check multisig, actually.
Oh, okay.
So, you'd have... multiple, say 2 pub keys, one of them's real and the other one isn't. And at that time, that was actually cheaper because it uses slightly fewer bytes of data than op return.
Okay.
But, that's a whole nother discussion.
Okay.
So op return, that was just recognizing that people were putting data in unspendable outputs.
Okay.
Now, op return, the meaning of that opcode is return false and fail immediately.
Okay. Can you explain that a little bit more?
Well, remember in Bitcoin, outputs are encumbered by little computer programs.
Okay.
Return false means, well, validation fails, thus output can't be spent. So if you see a script pub key that starts with fail immediately, there's absolutely no way this can be spent.
Okay.
And that allows the consensus code to just not add that output to the UTXO set of possibly spendable outputs.
Okay, that makes sense.
Yeah.
Okay.
So this op return was partly a consensus change, but a consensus change that should have no effect.
How did you get interested in this? What was the problem that you were trying to solve?
Well, like I say, the problem was people were putting data in unspendable outputs, but not provably unspendable.
Okay, that makes sense. Not provably unspendable, but because op return has this sort of fail. What was the term that you used? The fail.
The opcode basically means fail immediately.
Fail immediately. Yeah. Okay,
yeah. And so I remember
provably unspendable instantly.
Yeah, and it's the standard way to do it,
which basically protects UTXO bloat. Is that effectively?
Yeah. It's just a way of putting data in the outputs of a transaction without adding it to the UTXO set.
That makes sense. Okay, so this should have been something that, so then the concept of op return, I assume, would be into.
Yeah, that part was relatively uncontroversial.
Yeah.
But then, there's a bit of discussion early on about exactly which opcode you use. There's a whole bunch of ones that have the same kind of effect. I think it was I proposed an invalid opcode. I think, if I remember correctly, Gavin Andresen proposed op return itself.
Okay.
And then, of course, the next step is, actually to write the code. And if I remember correctly, I wrote the code that doesn't add it to the UTXO set.
Okay.
But then I think it was Jeff Garzik who actually did the pull request to then make it a standard transaction. And that's where the politics started happening. Because then the question is, well, do you have limits on this? And if I remember correctly, what I advocated for was, given that we're trying to do harm avoidance, right? We want people to use this mechanism instead of another mechanism.
Yep.
There should be no limits.
I wish that everyone in Bitcoin had like a harm reductionist mentality. It seems like that's something that most people don't adopt. I think maybe that's just sort of like a cultural thing of human citizens.
A lot of people...
They're ideological instead of harm reductionists. I mean, in order to
they don't think clearly, I think is the way to put it.
They don't think practically. They think about
they want,
ideology, not like
they're
actual
triggered
outcomes.
by how much they hate these things and don't think through what the incentives are.
Interesting.
And I think it's fair to say I was proven right, and that the incentives are, if you don't allow people to do one thing, they're going to do another thing. And you can't discourage people by, yelling at them on the internet.
Yeah. Okay, so what was the argument? So the argument was basically like, how large can you let these things go?
Yeah.
But if they're not contributing to UTXO bloat, what are they contributing? What's the issue?
People had the idea that this was, spamming the chain or so on. And something I want to point out very, very carefully here is that the idea of spam is not just non-financial. Luke had already put a line in the sand here with Bitcoin Knots, as he was filtering out, or censoring, if you want to talk about it that way, financial use cases for Bitcoin.
You mean like Citria Layer 2 rollup? Is that what you're referencing
No. I mean,
now?
back in the 2013, 2014 era, Luke's Knots was preventing people from using Satoshi dice.
Oh my gosh. Oh, so he has a very long history of this.
Oh, yeah. This goes way back.
When was Satoshi dice? Maybe you could just give a little bit of a TLDR
so Satoshi
on
dice
Satoshi
was like
dice?
a gambling thing.
Okay.
And the way it worked was they had this set of addresses.
This was like in like 2014, 15, something like that?
I think more 13, 14.
It was early.
Yeah, it was
way
early,
back.
yeah.
Okay, so it was a gambling thing.
Yeah, well, it was this list of addresses, and each address was associated with an odds of winning.
Okay.
And if you make a payment to the address, they would, in a cryptographically provable way, that they couldn't cheat, determine whether or not you won. And if you win, you get your winnings back.
Okay.
If you lose, they send you a little bit of money back just so you see, oh yeah, you made your bet and you lost.
Super fun, non-monetary use case for Bitcoin.
Well, that is a monetary use. It's gambling.
You think that okay.
It is monetary.
Fair,
I paid a bet.
Right. But
and I get my money if I win. That's monetary.
Would you also call like layer 2s and scaling solutions monetary use cases?
I think there's a discussion to be made here, but let's be clear. Gambling is a monetary use.
Okay.
They were financial transactions. Remember, this is pre-Lightning.
Right.
There's no secure way to go do this other than the mechanism they came up with.
By this logic, are BRC20 tokens financial use cases?
Well, I'm not making that point yet, but I'm making clear this was this is not about a token. Okay. This was, I am paying a gambling site to make a bet. Okay. And if I win, I get my money.
Okay.
If I lose, well, I don't.
It was outside of the scope of savings and payments, maybe,
well, that is a payment. I paid a gambling site.
Right. I guess.
It's very hard to say this is not a monetary use.
The Bitcoin itself is also executing the not just the payments, but the actual game of gambling as
right, but
well.
I mean, how else could it possibly work? I made a payment. If I win, I get more money.
It's arguably like early
there's
Bitcoin
there's no
DeFi.
more simple way to do this, such that every bet has this property of being trustworthy.
Okay, so Luke hated this.
Well, let's be clear. So,
and who invented Satoshi dice? Who's like the godfather of Satoshi dice?
I forget the guy's name, but it was very early on Bitcoin.
At that time, was the community up in arms about this generally, or was most people didn't care?
One way to look at this is you'd ask, what percentage of Bitcoin transactions were Satoshi dice? And at the peak, it was like over 50%.
Because it was not for hodlers, right? Like by definition, it was probably not a ton of people, but a ton of transactions.
That kind of discussion hadn't been, like the hodl whatever stuff hadn't been so prominent then.
Like people were using it as payments more, Bitcoin as payments at that time?
Yeah, a lot of the discussion was about Bitcoin as payments. But when like 50% of your transactions are this one thing, a lot of people then say, well, that's spam. But
you think that's what pushes people over the edge into thinking something spam is when it's like, this is too much.
So the points I want to make here is there isn't clear definition here.
Exactly.
And like a lot of this, you couldn't make an argument.
Term.
Yeah. I mean, let's say hypothetically, like buying coffee at Starbucks was really popular. I would not be surprised if Luke had gone and said that, yeah, buying your coffee spam too.
I mean, yeah, you can call it spam is a subjective term by definition. I mean,
yeah, and I think this shows how even a thing that does look like a monetary use case, they'll still call it spam. But anyway, so
they make no distinction between Luke makes no distinction between monkey pictures and BitVM data, for instance.
Yeah. Anyway, so that discussion already happened, and simultaneously there were things like Counterparty and Mastercoin that were, for their own monetary use cases, putting data in Bitcoin outputs.
That's true, yeah.
And I did some initial research on this. I mean, my very first paid Bitcoin job, full time, was supposed to be Mastercoin's chief scientist, which was hilarious because they ended up firing me pretty soon after because I wasn't really doing the promotion they wanted. I actually did the role of chief scientist and I studied the tech behind it.
Oh man,
they didn't really want that, but I kind of knew that would happen. It was fine by me. But Mastercoin was trying to go do tokens on top of Bitcoin. And again, this was one of these discussions where so many people hated this, but there is no secure way to implement this
stop it.
Well, it's not that. There's no secure alternative to what they were trying to do.
They needed it. This was a real use case for Bitcoin in their mind.
Yeah. If you have this problem, you are going to wind up using Bitcoin this way. Now, maybe you can use Bitcoin in a more efficient way, but that's separate than is this fundamentally spam idea? Yeah.
It's interesting because it also brings up, I remember, when I was kind of first getting into Bitcoin and I was very, very entrenched in just at that time, I guess people were calling it toxic Bitcoin maximalist culture. I don't know if that's still a term people use, but that was sort of my crew for sure. And I remember people the major argument was there is no legitimate use case for blockchain technology other than for money. There's
even worse than that. There's some people who go so far down that path. They say there is no legitimate use case for blockchain tech.
Exactly.
The entire category of blockchain.
No, exactly. Yeah. That's what I was told. And they made and there was a compelling argument at the time that I completely bought, I completely bought the argument, which was blockchains are inherently clunky, they're inherently slow, they're inherently this, that, there's really no
and I've spent something like 10 years going and pushing back at that.
Have you?
Yeah.
Hit me with your best shot.
Quite simply, let's suppose you have a centralized database. Completely centralized, it's, GovCoin or whatever it is. I will make the argument, and I think I am very correct on this, that even if you have a completely centralized database, you really want to have a blockchain just to make sure that the state of the database is correct.
Yeah, no, it makes sense to me. Yeah, exactly.
A blockchain is just a chain of blocks. Right. It's not at log.
Right.
Now, there are more efficient implementations at the cryptographic level to do certain things one way or the other.
Right.
I might use a Merkle tree in some way or whatever. But the basic concept is we just have a log and we go through the log step by step and we update the state of our database.
Yep.
That's all it is.
Have you always taken the position that Bitcoin at its core is a database? Was there ever a time when you were like, a Bitcoin is money?
Well, it's a replicated database.
What does that mean?
So if you have a Bitcoin node and I have a Bitcoin node, the purpose of the blockchain is to make sure that the database of UTXOs is the same on your node, the same on my node.
Right, that makes sense.
Yeah. Hence, replicated state.
Okay.
And again, going back to sort of the GovCoin example,
right,
or even something like, Walmart's main procurement database or something. Even if all they want to do is have one database and then have a backup, somehow they got to make sure they're in sync.
This just seems like this is just an objective, factually accurate way to describe this technical system.
Yet in the tech world outside of Bitcoin, and including it within Bitcoin, so many people, their answer to, well, let's use a blockchain is, no, that's stupid, just use a database.
Right.
And they just completely miss the point that no, of every blockchain thing tends to have a database, and the purpose is keep the database in sync. Because it actually turns out to be very hard to make sure two different databases are actually in the same state.
Right. That was sort of the arguably, that's another way of describing the invention of Bitcoin.
Yeah. It's just a way of keeping databases in sync.
So, do you think, when people use, if I say, people as a database and somebody says, no, Bitcoin is money.
Well, actually, I'll give a good example. My own open timestamps project, I haven't gotten around to it yet, but one of these days, I'm going to add some kind of blockchain-like thing to it solely for the purpose of making it possible for you to download the full sets of data necessary to validate any open timestamp proof and ensure that your copy is the same as my copy.
So this will be a non-Bitcoin blockchain, basically.
Yeah.
Yeah. And remind me why you would want to have a separate blockchain for that as opposed to
because all the data is not on Bitcoin, right? There's this whole pile of data. Oh, you mean
for the backup data, basically? Yeah. Okay, got it. And you would need a different kind of blockchain in order to do that. You'd need a blockchain with different efficiencies, different whatever.
Yeah. They're a very, very different cryptographic structure
different
than Bitcoin,
architecture of a
but
blockchain.
Fundamentally the same idea. It's blocks. It's a chain of them. And you process them one after another to make sure you're in the same state as me.
Right. So this has always been your point of view, basically, from day one. You're like, this is factually, objectively, this is a piece of technology that can be used for these things.
Git, the revision control system that basically every programmer on the planet uses, it is this close to being a blockchain. And the only difference between Git and what you would call a blockchain is that it isn't necessarily a chain. You might have 2 Git commits that refer to the same parent. And they can go split and branch off. But conceptually, the way people use it is basically the same thing as a blockchain. It's just the little details of exactly how the hashing works that's slightly different. But again, the reason is you have source code. I want to make sure I have the same source code. I check the top level hash and I make sure everything hashes up to the same thing. So
what was the resolution of let's call it the 2014 early op return war, and you and Luke were sort of the key players debating this at the time?
No, I don't know it was me and Luke per se. I think it was a bunch of people.
Okay.
But basically, the op return well, first of all, there's only one op return allowed per transaction.
Okay.
By the standardness rules. Consensus, obviously, and do whatever you want.
Okay.
But by the standardness rules, only one.
Okay.
And then secondly, the size of the data could only be 40 bytes.
Okay.
And the idea there was,
that was from day one of Bitcoin.
Well, no, day one of it becoming standard. Remember, from day one of Bitcoin itself, when Satoshi actually released the first version of Bitcoin,
right?
There were no standardness rules.
Okay.
You put anything you
but
wanted
there
in
was
transaction.
op return, right? Because that's where he
technically op return actually worked differently, which was a big mistake.
Okay. Yeah, so, what was the original? Because you always hear
originally op return returned the top stack item, which due to how Bitcoin in the very, very early days worked, it meant you could spend any coin by putting true op return at the beginning of the script sig, as it's called, which then to the interpreter says, okay, return true. I can spend the money. Yeah, that was an exploit in the early Bitcoin. And that's an op return got changed to being returned false.
So he closed that exploit. He fixed it. He fixed it. Okay.
Yeah, and there's a bunch of other little changes along there. But yeah.
But what were the data limitations on op return?
Well, there was no
data.
Remember, in very first version of Bitcoin, there was no concept of a standard transaction.
Oh, because data limits are standardness rule. They're relay policy. They're not consensus.
Yeah, there was no relay policy. You could broadcast anything that met the consensus rules. Absolutely anything.
All right, guys, I want to take a quick break to thank you for watching and remind you to click the follow button on my profile if you want more Bitcoin technical deep dives like this. I also want to give a shout out to my partners for making the show possible. My leading partner, Best in Slot, just released the programmability module for BRC20, making the execution of smart contracts possible for the protocol. I know that's been long awaited by the BRC20 community. Alongside this release, Best in Slot put out what is arguably the most sophisticated DEX for trading Bitcoin native assets called Coin Cooker, which I also highly recommend checking out if you want to dive into the BRC20 trading game and get started executing smart contracts on Bitcoin. I'd also like to thank Cetrea, building one of the leading implementations of a BitVN-style bridge for Bitcoin. Cetrea is building what I think could become the canonical Bitcoin rollup, enabling programmability, scaling. Really anything is possible with a trust minimized bridge, which is the unique value prop of these BitVM-style rollups on Bitcoin. Lastly, I'm thrilled to announce my newest partner, Spark, which is the leading state chains protocol on Bitcoin. State chains builds upon what was made possible by the Lightning Network for payments, but without the liquidity constraints and the UX challenges that often make self-custodial Lightning impractical. Spark is also led by one of the leading payments infrastructure teams on the planet, including founders from PayPal, Facebook, They're incredibly well positioned to turn Bitcoin into a true institutional standard for payment systems around the world, and I couldn't be more excited to support what they're up to. All right, on that note, let's get back to the show.
When did the concept of standardness and relay policy come to be?
I think date-wise, maybe 2011. Don't quote me on that.
And why? I mean, do you want to just like TLDR for people? Like, why do we have relay policy? Like, why was it instituted?
I'll answer why we have it now. I hate to say this, but Satoshi didn't fully understand Bitcoin. Okay. The people around at the time didn't fully understand Bitcoin.
Yeah. It was like, right. Makes sense.
I'm not going to speculate on exactly why they did it, but the reason why we have it right now, the main reason is to provide upgrade hooks.
Okay.
So
what does that mean? Yeah.
Well, so a good example is when we implemented check sequence verify, we needed to add a way for a transaction to be invalid unless a certain amount of time had passed from when an output was created.
Okay.
All right. That's a new feature. That's a new feature
thing.
We added.
Right.
Did not exist in Bitcoin, from the beginning.
Sure.
And the way we did this is we said, well, transactions have version numbers. The version number had no consensus meaning in the first version of Bitcoin. It was just a number. Didn't mean anything at all. Now, the wallets would set that number to 1. And then we decided, well, we'll add code that if the number is greater than 1, we will treat the end sequence field in transaction inputs as potentially having the meaning make the transaction invalid unless enough time has passed.
Oh, so that was the first use for relay policy, basically. That was like the reason to institute standardness.
Well, again, it's not necessarily...
Something non-consensus, something other than a consensus rule.
Point is, like I say, I'm not going to speculate about why it was added initially, but what I'm saying is the reason why this exists now, the number one reason is to allow these upgrade hooks. Now remember, so I gave you an example where a field in a transaction, normally people would set it to one thing, and we gave it an additional meaning later. Now, imagine you are running a node, especially a mining node, that doesn't know about this change, because this is a soft fork. We're making something that was previously valid invalid. You don't want to mine transactions that are now invalid.
No.
So standardness rules means all of these like little technical hooks that allow you to do upgrades later. Anything unknown, you just reject.
Okay, that makes sense.
So if you don't know what it means, you just reject it.
Somebody was telling me so.
Like, and to be clear, if it's in a block, if you don't know what it means, you accept it, right? Because that's the way the upgrade can be backwards compatible. But you don't want to put a transaction that you don't know what it means in your block, and you don't want to relay it to others.
So this is an example of a standardness rule, essentially, that you're describing.
That's the primary reason why they exist.
But we have like a million other standardness rules.
No, we don't.
No, we don't. Well, what about all these data limitations that we're talking about? Are they relevant?
Well,
I mean,
they're disappearing. Remember, in V30, we removed the entire class.
Why did we ever have these standardness limitations? What was the point of all these?
Hang on. So I gave you the main reason standardless limitations exist.
And is this an uncontroversial point of view? Just so that...
Fairly uncontroversial.
Okay, fairly.
There's some crazy people might say other things, but that's certainly a reason why these things exist.
Okay.
And I would say it's the primary reason.
Okay. But we have a lot of other, like, again...
Well, we don't have very many. So
how many data limitations?
All right. So with that class of standardness rules.
Okay.
The second class we have is to prevent certain exploits in version like zero scripting, like the thing Bitcoin was created from the very beginning.
Okay.
Satoshi screwed up. There's a bunch of like things there that could basically make transactions take really long to validate.
Okay, so it's like DDoS prevention.
Yeah. And key thing is, as a miner, in most circumstances, if you're a small miner, you don't want these transactions in your blocks, because the block will take a long time to propagate and you're going to lose a pile of money. So that all gets filtered out. Now, in the future, we might fix these exploits by making that type of those types of transactions just totally invalid. And they're all kind of edge cases. Like an example is, you do tons and tons of signature operations that would never be necessary for a real transaction. But because you do them so many, it just takes a long time to process that transaction. If we make that transaction invalid, this problem goes away. And we've made these transactions non-standard to avoid this problem.
Okay.
Yeah.
All right. So it's not a ton. There's not a ton of standardness rules.
Yeah. Now there's
one
more category which is kind of like that, which is just the size limit, and that gets down to the way we build blocks is kind of dumb, and if you allow really big transactions, you can make dumb economic decisions where like you allow one transaction in, but you would have actually made more money by, say, allowing two smaller ones. And if the maximum transaction size relative to the block itself is small, the level of the impact of that mistake is limited.
Is that really relevant though in like modern mining where like people just have
it's very relevant.
You think so?
Yeah,
but
anyone
computer
running
programs
Bitcoin
aren't just like able to just like optimize like what the best.
You can tell me. Does Mara do something more clever than what Bitcoin Core does there?
Well, but this is my point.
Because my understanding is they don't.
No. But this is the point.
Well, which gets back to the simple way to do this is just say, don't make transactions too big, so our dumb greedy algorithm works. And this is something that could be fixed later, but it's just a lot of work to do, and like no one really wants to do it.
So is that specifically where the size limitations
that's where the size limit comes
play?
From. Yeah.
Okay, so the size limitations are about helping miners make better economic decisions.
Yeah, and it just keeps everything easy. And also, the size limitation makes exploiting some of these DOS attacks harder.
But obviously, like Slipstream, for instance, is bypassing these rules and allowing
but I
this
mean,
to happen.
Slipstream can do this because they charge a ton of money relative.
So
to
basically,
the
they're like, it's just we know that it's economically in our interest to do this because we're charging a premium.
Yeah, and there certainly would be cases where I could trick Slipstream into actually making less money.
Interesting.
Yeah.
Okay. So then that's basically the thing. Is we want miners to be economic.
There's your three that's easy to defend. There's solid technical reasons for this.
So you don't think that relay policies around data sizing specifically should be eradicated? The system as it currently exists where it's like, no, you just have to pay a premium.
Remember, I never said anything about data size. All we ever talked about here was...
Data limits?
The total size of a transaction, which has nothing to do with whether or not there's data there.
Okay, fair. Okay.
Now... The two, there's one class of like nuanced rules about RBF policy, but let's not get into that. That's a hard one to explain, and again, that fits into there's good technical reasons for this.
Okay.
But then the final thing that as of V30 we disallow that's really relevant is something called the Taproot Annex, which is every Taproot input. There's this optional data field that has no consensus meaning at the moment, and it can be any size you want.
The Annex is so hot right now. I feel like there's like a push to try to like make this happen and like bring the Annex back.
And notably with op return, eventually, 10 years later, we finally realized, you know what? People are going to do this, and we might as well just relay it. Taproot Annex is probably going to be the next thing there.
Well, I was going to say, do you think a lot of people will use the Annex for things that they're currently using op return for?
Well, I mean, no one would use op return if they didn't really have to, because op return is 4 times more expensive.
You mean people would just put it in the witness?
Exactly.
Why is Casey using, for instance, op return for something like runes then?
I hate to say this, but I suspect the main reason is because it makes Luke Jr. angry.
So he intentionally was like, we're going to make this expensive just to piss him off.
The whole design of, first of all, ordinals predates inscriptions.
Right.
They made ordinals, they created those indexers, and no one cared.
Right.
Maybe not no one, but approximately no one cared.
Right.
Inscription comes along, and I think had Luke not responded to inscriptions, no one would have cared.
I actually don't disagree with you. I was managing comms for Casey at the time, and I'm fairly sure that you were right about that.
Yeah.
They were the best marketing that Casey could have ever had.
And there's all these little technical decisions in these protocols, which frankly are dumb from a technical point of view, but they're great at creating Twitter drama. And
apparently,
like it or not, I mean, this kind of describes a lot of it. Now, at the other extreme, I mean, I've done work on things like RGB. Arguably, I'm the guy who came up with that idea, client-side validation, arguably. And RGB uses a lot of that stuff. And my work on this has been figuring out ways to make this extremely efficient and very hard to censor. And I would say, at least on paper, we've succeeded at that. Obviously, someone actually has to write code to do this, which is a whole epic, but we understand how to do it. And a system like RGB with only acceptable trust assumptions, that's a complex discussion, but with good trust assumptions, you could do like billions of transactions per second. And this data doesn't have to be on Bitcoin. Now, Knots guys are going to complain about the small amount of data that does have to be on Bitcoin.
Right.
But I don't care. They can't stop us.
So let me ask you, what do you think is effective relay policy? Because, and back up actually, before I get into your kind of political point of view, tell me about Libre Relay and what that is and why you created it.
So I like Greg Maxwell's description of Libre Relay, which is it is a performance art project.
A performance art project is a great way to describe it.
I mean, keep in mind, I'm a weirdo with a fine arts degree, so, he's saying this for a reason. But yeah, it's a performance art project that shows that Bitcoin Core should not try to go censor transactions.
Okay.
And the way it shows that is by bypassing Bitcoin Core, and for that matter, Bitcoin Knots relay policy, by ensuring that Libre Relay nodes are connected to each other, and thus their Libre Relay policy successfully propagates transactions. Now, when I first used this technique for the full RBF debate, which was this whole other separate relay policy thing, and I finally won that one. But that took took like 12 years. But I first used this technique of like nodes connecting to like-minded nodes to get RBF working. Later, full RBF.
Yep.
And basically speaking, like I won that debate, but then op return stuff came along. So I dusted off that code basically and reused it, calling it Libre Relay.
Oh, so this Libre Relay was basically like the similar architecture to what you had previously done with RBF.
Yeah, in various versions.
In order to essentially make a point and prove that something...
Yeah. I'll make a point with RBF. I think it's fair to say I was making something actually work. You were providing a real function. You're providing a real function with Bitcoin Libre to the monkey holders. No one called my full RBF peering code a performance art project because it actually worked.
Right.
Libre Relay, I think, Greg Maxwell isn't going to approve of it. Isn't going to approve of those use cases on like full RBF. Hence, we call it performance art project. But regardless, what it does technically is it makes sure that this less restrictive relay policy actually works.
Right.
In a good good contrast here is Bitcoin Knots implemented full RBF by default years ago. And prior to full RBF becoming default in Bitcoin Core, there was this time period where I hadn't been maintaining my peering code, and Knots nodes would advertise via service flag that they did full RBF, just like my peering code nodes would. The problem is the Knots node wouldn't actually seek each other out. So they'd be kind of like their own isolated islands with Knots nodes. And they'd be surrounded by non-Knots nodes that wouldn't do full RBF.
Okay, so they would get blocked.
Well, blocked maybe isn't the right term here. I'd say they were ineffective.
Right. They had traffic jams.
Yeah, they had this less restrictive relay policy that was made completely useless because they weren't connected to each other.
Wait, so you and Luke were on the same page about RBF?
Full RBF.
Full RBF. Yeah. Okay. So you've had, certain things where you were lied, certain things where you were less
full
lied.
RBF was this weird political thing because I don't think, for the most part, people didn't really disagree with me, but no one wanted to wade into the political nonsense of making these so-called like zero conf Bitcoin use cases finally clearly dead. So that dragged on as sort of like a zombie use case of Bitcoin that people didn't actually do for years. It was a little ridiculous. But what finally put the nail in...
It seems pretty straightforward. I mean, full RBF basically just means that transactions automatically are eligible to be RBF. Is that accurate?
Yeah. I mean, it's
pretty obvious thing to do.
We expect miners to mine what makes them the most money in the case of conflict.
Yeah, I don't see why that would be controversial at all.
Well, I mean, we expect miners to make the most money. Well, what if it's about a monkey butt JPEG?
Yeah,
right?
I guess so.
I think the Knots guys, they have this idea that we expect Bitcoin to be run by people who will do things that's not in their financial interest for the greater good. That doesn't really sound like the ethos of Bitcoin.
No, it doesn't. Yeah. It doesn't.
And, in the academic community, this has been something which I think a lot of academics get very wrong. They talk about Bitcoin with what they call the honest node assumption. And
which is?
Well, academia uses this kind of discussion a lot. They'll talk about a protocol and they'll say, well, they're honest participants. And if there's enough honest participants, the protocol works. But honest in academia speak means following the protocol exactly.
Oh, interesting. Okay.
And when they talk about this, they often mean things that are completely against the financial interest of participants. Whereas Bitcoin isn't perfect, but it's fair to say that the assumption in Bitcoin is people maximize their financial interests. And in particular, they tend to maximize their short-term interests. If you talk about long-term interests, you can always go and come up with some story about how doing the right thing is in their long-term interests, which is usually not very convincing.
Right.
But short-term interest is easy to talk about.
Right. Well, it's more quantifiable. It's also easier to predict.
Yeah. In the case of miners, well, when you make a block, what transactions you put in? Right now, miners, roughly speaking, they go from the highest fee rate transactions to the lowest.
No.
What makes the most money fastest?
Very straightforward.
Yeah. And there's some nuance about exactly how that works. There's certain cases where Bitcoin Core isn't quite optimal, but it's pretty close. And removing the opportune limit is an example of getting closer to that ideal.
So when you say, you developed this Libre Relay, which basically is like a system of nodes that are connected to each other that basically just don't enforce standardness rules, essentially.
Well, no. And that's a very common misconception. Remember, most standardist rules have solid technical reasons to exist.
Okay, so you include the solid technical ones that you think are legit.
I mean, let's put it this way. Libre Relay is nearly identical to Bitcoin Core. I add the code to connect to other Libre Relay nodes and advertise that you're one. I removed the opportune limits, which is no longer relevant. I add Taproot Annex in a standard way to do it. Notably, though, I add a standard way. I don't just remove, I don't just say any Taproot Annex is fine. To avoid something called a pinning attack, I require if any input uses Taproot Annex, they all should. And then to allow for use of Taproot Annex in consensus in the future, I say either the Taproot Annex has to be empty in an input or start with a byte 0.
How many nodes are currently running Libre Relay?
Probably 50-ish.
How fast are transactions typically getting confirmed when they use Libre Relay for submission?
Well, it depends on what transaction you're actually talking about.
Okay.
Right. But let's say,
because some other nodes may or may not relay it.
Well, it's not that. It's what percentage of hash power. So a good example is...
Right, which miners will mine it.
Yeah. So a good example is if you go and use...
Slipstream will mine pretty much anything within consensus.
So if you use Taproot Annex, at the moment, I think it is Mara and F2 Pool who will mine it.
Right.
Maybe Spider Pool.
But there's a handful of other public miners that will that have more gray area, these rules will accept, these we won't.
Well, so another example was even before the defaults getting changed to less than 1 sat per vbyte.
That was you, right? Were you the first person to submit a less than 1 sat per vbyte transaction?
I certainly wasn't the first.
You weren't.
So the way that played out was I noticed, I think it was Spider Pool, if I remember correctly. I noticed Spider Pool was mining them on occasion. I knew
who was submitting them though. I mean, who was attempting to do this?
I really don't know.
Okay.
My suspicion was Spider Pool had some deal with someone where they would manually add it to their mempool.
Interesting.
But the thing with that
maybe somebody was trying to consolidate UTXOs or something. Why do you think somebody was?
Oh, I mean, there were a bunch of miners who'd had that kind of deal.
Okay.
But I noticed they were doing it. I knew Mara would under certain circumstances because I knew Mara had set that limit lower. And I knew hypothetically some other people might. And I just made the guess, well, you know what? I might be connected directly to these nodes. Because, they, this wouldn't propagate over the rest of the network in general because the default is set higher. But I had some very well connected nodes and I just manually set that limit lower on them. And I changed my open timestamps calendars to produce transactions with less set for vVite. And the thing is, those calendars are producing transactions like every day. So there's this constant set of attempts, and there's a public dashboard for those calendars which shows the transactions as they get mined. Well, what do you know? They started confirming, among other ones at Spiderpool. And then, of course, I go say on Twitter, hey, you know what? This works.
Okay, so let's really quickly just like hash out again the standardness rules that you basically evicted from Libre Relay, or evicted from core to create Libre Relay. So one was, so we had the Annex. You can
at the moment, that's the only thing.
Oh, it's just the Annex now.
That's
wow, that's going to be some performance art for the Annex. Is that why the Annex is getting so much attention right now?
Well, it's potentially useful.
It's also very useful.
Yeah,
I've
useful.
heard so many interesting use cases for the Annex.
I could go reduce the dust limit.
Okay, but you haven't.
Yeah, I haven't.
Why?
Because there's a bunch of work to do, and no one wants, no one's offered to pay me to do it yet.
In your mind, that's a rule that could go, and it wouldn't be a big deal. You're like, whatever.
Yeah, well, the problem it tries to solve should be solved at consensus. And if there is demand to create transactions that violate the dust limit. Satria apparently is an example of this.
They would really love it if you did that.
Yeah, I was talking to them yesterday about maybe they'd be willing to pay me to do it.
Right. Yeah. I'm sure. Yeah. I'm sure they will. Yeah.
Well, we'll see.
Yeah. I mean, it would be worth it for them to do it, I think is the point. It's interesting though. So, okay. So, but as of right now, so you made an interesting comment that I just want to call back on, which is you said, this is performance art to make a point that Bitcoin Core shouldn't censor transactions, because basically this proves that censorship doesn't work.
Keep in mind that there's always been this pressure for Bitcoin Core, from Luke as an example, to add more filters.
You think Luke is the primary person that's putting this pressure on
He's the figurehead of this.
He's the figurehead of the add more limits.
I know that...
and his intention in doing that, just for clarity, is to limit arbitrary data specifically on Bitcoin.
Not just that.
What else are his motivations,
Satria
do you
isn't
think?
really arbitrary data.
It is. It's just a real financial use case. That's my argument.
But it's not data. That's the thing.
It's not.
It's like.
Well, it depends. Some of the things are data, and some of the things aren't.
Well, I mean, if you say it that way, everything in a transaction is data.
Okay.
Right.
Okay. But you're inscribing information other than just like UTX, like then the UTXO.
But I mean, again, the thing here is it's not arbitrary. It comes out of a system of math that's necessary for the financial use of their system.
But this again starts to get a little subjective, to be honest.
Well,
right?
so an interesting example of this is there's certain types of Lightning channels people proposed where they would use Taproot annexes to broadcast data that is necessary to go and allow your counterparty to recover funds.
But I would argue, though, that like this is where we start to get into the definition of arbitrary data being subjective.
Hang on.
At what point does BRC20 tokens in Bitcoin DeFi
do you understand how HTLCs work?
No, please tell me about HTLCs.
So in Lightning, every payment, the contract a payment represents is roughly speaking. So yeah, let's say I make a Lightning invoice.
Okay.
Make a Lightning invoice for 10 Satoshis.
Okay.
The definition of valid payment is you can prove that there exists this preimage, this message that hashes to a certain hash digest.
Okay.
That's the definition of payment.
Right.
If you can provide that, by definition, that's paid.
Okay.
Now, the way this ends up on chain is you actually put that message in a transaction
to prove that you
to prove that you paid.
Yeah, so I would call
that message is arbitrary data.
I would call that arbitrary data. This is my point. But I mean, to your point, arbitrary data we've been putting on Bitcoin forever. It only pisses people off when it's use cases that they don't like. It's all arbitrary. In my opinion, this is my definition. I have a very specific definition of arbitrary data because I don't necessarily. It's like, where's the line? It's like, again, BRC20 tokens.
Well, obviously the line is what Luke doesn't like.
Exactly. If Satoshi Dice is a monetary use case, you cannot say that BRC20 is not a monetary use case in that situation.
I could ask Luke. I don't have an opinion here.
I guess you got to ask Luke. Anyway.
I mean, to be clear, have I told you about my other project that's coming up?
No,
so
which one?
So I have Libre Relay.
Okay,
then I also have Luke Relay.
Luke Relay.
Yeah.
Okay,
so every time
it
receives a transaction, it's going to tweet at Luke on Twitter. and then ask him a poll, yes or no.
Perfect.
Yeah.
Perfect.
Yeah. Okay, not many transactions have gone through lately. It's kind of sad.
I want to just finish my previous question, just see what your response is. So your point of view is that Bitcoin, you were like, Bitcoin Core should not censor these transactions, and this is performance art that basically proves that it doesn't work, and it's silly to attempt to do that. So, I mean, you're kind of basically making the argument that that a lot of these standardness rules were essentially attempts at censorship.
Well, so the term I've used is they are paternal standardness rules.
They're like, we know better how to use the chain than you.
Yeah. And again, I will say very clearly that there are definitely standardness rules with strong technical reasons, and that's
and those should be included.
Yeah, and that's mainly the upgrade hooks.
Hooks. Okay. Anything else other than upgrade hooks? Just for.
I mean, right now, the anti-DOS thing is necessary, but it would be good to fix that.
The anti-DOS thing.
Yeah,
okay.
That would be good to fix. It would be cool to be able to remove this maximum transaction size limit, but that means some poor guy is going to have to spend like half a year working on mempool like code. So
right, might not be the highest priority thing in the world.
Yeah.
Okay,
it's, and also, I mean, that's a use case that's rare enough. If an entity like Mars Slipstream takes all that business, I don't really care that much.
Yeah,
like it's bad.
It's not enough business for them to make a huge difference in terms of like miner centralization.
It's bad if centralized miners make more money the non-centralized ones, but the difference is like 1%.
It's minimal. Yeah.
Who cares?
Yeah, right. Yeah. It's just not enough MEV to make a real like substantive debt.
Yeah.
So Annex, I feel like, this is all sort of like coming to this head. I feel like the new precursor is, well, I have a couple things actually that I want to conclude this conversation with. One, where do you think this op return war that we're currently in, this like version of the war, is heading? I mean, I did hear from Matt Hill, who I interviewed yesterday, who's the CEO of Start9 and selling a bunch of nodes to people who want to run knots. He basically said that he thinks that there's going to be a soft fork proposal that will be contentious in the next 6 months. Do you see that happening? Like, where is this going? Wait,
which soft fork proposal will be contentious?
Didn't say.
I mean, they're all contentious.
Right, fair. But he was very cryptic.
I mean, so all right, so I'll still man this, but I'll say, I think that they want to do some kind of soft fork with the intent of applying their filtering rules to consensus. And from a tech point of view, the Bitcoin Core side is going to say that is ridiculous.
Yeah.
Because obviously anything you write into code, the people who want to do this stuff is just going to work around.
But if it's at isn't the whole point of their, like, if it's at consensus level?
You cannot prevent arbitrary data from being published in Bitcoin transactions.
Even if it's at consensus level?
Yeah, it is mathematically impossible.
How? Because they'll just find like a new place to put the data. And
No. What was the name? Mononautical. Yeah. So, they had a good write-up on, was it BitMEX Research? That's who did it. Yeah. I think I right name. Yeah. So BitMEX Research has a good write-up on how you can hide arbitrary data in basically signatures themselves.
Right.
And it is mathematically impossible to go and determine whether or not data is in a signature.
Okay, so basically you're going to incentivize really bad behavior if you try to put like
it's not about it being bad. It's not about the incentives.
But it's just worse.
We can't stop it.
Right. You can't stop it.
And you would have done a soft fork, which is always this disruptive thing, and accomplish nothing.
But it's sort of not to, I'm trying to think of like a let's use like the war on drugs or whatever. It's like you're just going to end up creating black markets if you try to outlaw drugs, right? It's like,
I would actually say no, that the war on drugs is actually a great analogy here, because in the war on drugs, so with op return, that's a reasonable enough analogy. In that, they could do this thing that's more harmful. We'd rather them do this. But for this just arbitrary data in general, I mean, it's almost like if the answer in the war on drugs was everyone would just go hand from one person to another, little plants that just grew anywhere with zero effort, and it would just create cocaine on the leaves. It's just once you get to the point where you decide, all right, we're going to go put data in signatures, you've lost so thoroughly
the plot.
Yeah. And I mean, marijuana is kind of like this. I mean, you can grow marijuana in your backyard. It's just, you can't grow it as well as the guys who've really dialed in their processes.
Right.
But, imagine we lived in a world where someone had made like the cocaine plant and it just grew no matter how badly you treated it, in like raw cocaine just fell out of it.
So the
like
core
that's
point
what
here,
the tech is like.
The core point here is like, it's just silly. Like you just can't prevent it. It's just not. But it's kind of like they would make the argument, shouldn't we at least try? And I think there's some argument pushback to say, well, trying might create worse outcomes.
Well, I mean, the way I'd put it is, no, we shouldn't just try because it's a lot of work and disruption. Why don't we focus on real things?
Yeah.
Like, why aren't we doing a soft fork for like the Great Consensus Cleanup? Right? I mean, it would be really good to get rid of these silly DOS attack issues. It'd be really good to fix the time warp attack. I mean, there's a whole bunch of opcodes people would love to do confidants. Me personally, I'd like to see my op expire proposal done.
The argument there, though, from them would be, though, that like this is arbitrary data is harmful and it is a problem and this is a real problem worth solving and putting energy into. What's your argument to that? Or
and
what's
I
your
would
counter?
say the sane way to look at it is the issue with that is higher fees. And if you actually cared about higher fees rather than the purity of the chain, you would want Lightning to work better.
Wow. Okay. Next episode, we'll come back. Are you a Lightning maxi? Do you love Lightning in the L2 space?
Who wouldn't love
space?
Lightning?
Oh, I feel like Lightning is kind of having a moment. You heard Paul's talk yesterday. I mean, Paul thinks that Lightning is
No, I didn't hear it because he's stupid.
Paul thinks Lightning is dead. Paul
Yeah. Lightning is so dead. Yesterday, I may or may not have bought a bunch of US dollars with Lightning person to person.
Oh my gosh.
Just to get here, I would have booked like 3 plane flights with Lightning.
You booked 3 plane flights with Lightning yesterday?
Well, yeah. In the process of getting here to figure out my travel.
Okay.
One flight here. Well, one set of flights here, one set of flights back, both on Travela, and then one other flight for like a different conference I had to go and arrange. And like that's just in like the past couple days.
Oh my gosh.
Like,
okay. All right. Okay.
I spend so much money on Lightning. I mean, I get paid in Bitcoin.
But you might be a unique user.
Well, but I'm not. There's nothing special about what I do. I go put money in Lightning like wallets and I just spend it and it just works.
We're gonna have to do like a part 2. Maybe I get
Phoenix?
you and Paul together.
Do you have Phoenix?
Yes, but I never use it. So that tells you something.
So do you ever spend Bitcoin?
Honestly, I am an on-chain maxi.
Well, have you?
Because I don't really.
Well,
like,
what do you spend? What do you spend Bitcoin on?
I pay my vendors.
Right. So in that case, I mean, your vendors probably aren't set up to actually do it. But if you spent Bitcoin at retail, like say buying plane tickets on Travela, your choice is either you put it on chain and you go wait, 10 minutes for confirmation, or you just go pay with Lightning. It's just instant. If you put the money on Phoenix and just was paying with Lightning, like you'd see, it's actually a very easy process.
I can't believe you missed Paul Stort's yesterday.
No, I was there and just left because, it wasn't saying anything interesting. Like, I've heard his arguments against Lightning. They're just dumb.
All right. Okay. Well, at some point, I would love to have you two on and hash it out. But
no, I'm going to charge money for that. He is so tedious to sit through.
He'd love to do it. I bet he'd say yes, by the way.
Well, you realize he already paid me to do an analysis of drive chains.
Oh, my God.
And I undercharged. I should have charged way more money for that.
Oh, my gosh. Okay, so really quickly, lightning round, because this has been great, but we're over time. The Annex. So, actually, no, really quickly. So finish. So you think they're going to put through a soft fork proposal for Luke and them are going to put through?
Good chance it'll end up being a hard fork proposal, which will be really fun.
Hard fork proposal. Oh, my God. How do you see that go? And if it's a hard fork proposal,
so one way it can go is there'll be a UASF, but then the UASF is likely to fail, and then they can do a hard fork to then make the UASF happen as a separate currency. They would need to do it.
They would do they're dependent on the UASF mechanism, basically, right?
Yeah,
that's their whole thing. Yeah, is node power
and UASF. From the point of view of everyone else, because they're not going to get hash power, it's just going to fail. And they'll be on their own chain.
Right. Yeah. Which, and
then one way to respond to that can be a hard fork for certain technical reasons, or they could continue on as a UASF soft fork and then maybe have like 1% hash power with Ocean, which would be just bizarre.
I don't want to put words in Matt Hill's mouth by any means, but when I interviewed him yesterday, one of the things that we spoke about was basically that, like, even though they know that they won't like win a hard fork war without economic nodes behind them, which seems unlikely in the situation for various reasons.
Changes aren't going to care.
But do they think exactly? But I think he sort of made the argument that if there's enough political pressure that like a fork is actually imminent, Core will then feel pressure to. You don't see that.
So good example of this is back in the
Core
SegWit,
will feel pressure specifically to like institute the relay policies.
Back in the SegWit days, when there was a UASF, if you were at a conference like equivalent to TabConf, all the discussion would have been about a fork and the pros and cons, how that would work technically, et cetera, et cetera, et cetera. In TabConf, all this nonsense, this is the only time I've really talked about it.
I was going to say, people haven't really been talking about it this week.
Why
I think people
they?
Are fatigued. I mean, by the time this episode's come out,
No, it's not because they're fatigued.
No.
It's because it's just a dumb topic and there's far more interesting things to talk about.
Fair enough. Okay.
And this is why this will go fail, because it just doesn't capture the attention of people who are actually competent who go use Bitcoin for real things.
I think that's fair. Wait, so on that note, that's a perfect place to finish off with the Annex. What's your favorite use case for the Annex? I predict that the Annex is going to get increasingly more attention, especially now that it is like the single...
The most interesting and simple one, which annoyingly, I can't remember off the top of my head what the exact details were, but it was for certain types of Lightning channels. If I remember correctly, it was the...
That's what it was originally created for. That was the...
No.
What was the purpose of it initially?
No, the reason the Annex was added was just to give ourselves a way to go and upgrade things in the future. We didn't have any idea what we'd use it for yet.
But we were just like, it would be great to have like a space here.
I can give you a nicer example of the Annex. So remember, I proposed op expire opcode to make transactions expire.
Okay.
So they'd be valid and then become invalid.
It's an interesting idea,
which has certain use cases in Lightning and other things.
Yeah.
And one way to implement it would be use the Taproot Annex to go and have consensus meaning to a tag in the Annex saying, this input says that this transaction is invalid after this point in time.
Oh, interesting. So you basically put like whether or not something expired, like the rules.
Well, here's the thing. Remember what I said about end sequence and check sequence verify? We did something similar to that to make a transaction invalid before a point in time, but we're out of fields, right? We can't just add another end sequence 2. What we can do is add an end sequence 2 like thing in the Taproot Annex. Which gets back to, well, that's why we added it.
I love it. I know some very interesting people who I won't name because I think it's private that have interesting use cases for the Annex coming up. I predict a lot of Annex talk over the next year, so I'm excited to dig into that more. But
sadly for me, I think all the talk will be about things other than my op expire proposal.
Probably.
It's not important enough to get in soon, but it's a cute use case.
It's a very cute idea. No, I love it. And I do think that Libre Relay will actually be potentially influential in the proliferation of the Annex conversation.
I mean, it's probably what people are going to use.
Yeah, exactly.
Of course, eventually Bitcoin Core is going to add it, and then I won't be able to get any funding to develop Libre Relay because it won't be any different.
100. and that would be a positive outcome. Yeah. There you go. Cool. Well, thank you so much, Peter, for coming. This was really fun, and I guess we won't be doing the Paul Stortz debate anytime soon. But
hey, if he wants to give me $5,000 for sitting down, I'll probably say yes.
Okay, I'll let him know.
Yeah, let him know. Yeah, I'll start high, maybe negotiate down.
Okay, cool. Sounds good. Thank you. Thank you for coming.
All right, thank you.